Okay, okay. So welcome all of you to the demonstration of all the summary of the new features which was developed for the last few years for Onedata platform, which is specializing for long-term data archiving and processing, which basically is built on top of the function of the service capabilities integrated into Onedata platform and be compliant with OAIS approach. So our today effort, the result is already included in the public production releases and in the releases which are even available on EGI Data Hub version 21.0.2. And this part of the platform was done in collaboration with the systems and GWDG in some of the archive projects in the past. But these things, what I'm showing is like a production release version. It's gonna be the presented on the demo platform, but as well, these features are available for those who have proper credits on for the proper access to on EGI Data. So to start today, of course, as you always, those who know my presentation, usually we are focusing on the part of the live demo. Before we to go on the live demo, I need to explain you a few basic concepts which are the fundamental for this part of our system. So, what is Open Archival Information System, and how it applies for the scientific data? Okay, so if you want to preserve the data, people very often think that it is always about the preservation of your bit or bytes of your data. But in practice, it's way more. We should preserve for the long-term data preservation. We should not only preserve the bit and bytes, but as well preserve all the other information in the way that many years from now, we are able to extract the data from the storage system in that way that we are able to extract all important things, how to use the data, how to process this in the future, not only be able to read the binary part of the data. So Open Archival Information System introduces the concepts of the how the proper preservation should look like for this, like how the proper archival should be organized. So in this kind of the typical archiving approach, we have the producer of data, which delivers a packages of data, which is called SIP, Submission Information Packages. It ingests the data into the system, the data management system, and the data management system should be able to properly validate, check some, validate the content, analyze the metadata, and save the data into the archival storage in the format which is prepared for long-term preservation. In that sense, that means that in the future, we are able to go directly to the storage system, even if the software management platform is dead, and we can extract the data directly from the storage system, and the data being readable in the future. So to achieve that level, they claim that we should reach the level of AIP optimization level of the packages in the format which will be accepted in the law. Now, on top of that, we have as well the features related to data management on top of those things. So we can easily manage versioning these AIPs. We can easily produce new versions. We can easily do other processing of this data in the future. And last but not least, we are able to deliver the access to this data, because this is not only about the archiving, but as well to giving the access to the data, giving the access to the interfaces, public or non-public, depending on the policy. But we should be able to discover the data. We should be able to as well to get the data out of the system in the lightweight format, which is a distribution information package way. So let's imagine when we have a huge data collection, with the images, we could have their simplified images just to browse the data without reaching the AIPs. And in the end, when we want to get the AIPs, we can get the full packages. And there is an exit strategy in the system. So the producer can put the data into the system and later extract the bits from the system in that way that it's not losing properly to make the system. It's not about being identical test in binary, but it's being in the way that it matters and is valid in the future. So today we will be mostly focusing on the SIPs because in practice, the most difficult part of the system to make is like proper for the end users, so they can properly deliver the packages as it's very poor in the market in terms of the standards in this approach. So what is the submission information package in practice? In practice, we want to deliver data in the system anyhow. We have the users, which we are using our system, who want to just push the data in our platform. So they treat our platform as a service where they can push the data. So they can use a web graphical interface, just drag and drop the data using a REST API, CDMI, or we recently introduced as well a new S3 protocol in our system. So we are able to speak S3 to our clients, and they're able to push some information into the system. And there is another approach. When you have this push works fine if your data is reasonable small. If the data is huge, if you are talking about the hundreds of terabytes or petabytes of data, this automation might be a cumbersome for you because you need to manage the problems of losing connectivity, restarting, all of these things. Usually, this our clone features, they are handling this better or worse approach. But if you are using a pure web or pure REST API, the resilience of that part is limited. So there is a better approach. It's a pull approach. So our service is pulling your data or it's scrapping the public repositories from using the internet out and being downloading that into the platform, be late for later archive, for later archivization. So in that approach, we have like our own old method, which we was like promoting for years. So you can deploy your own gateway, Onedata gateway, close to your data, close to your NFS or S3, whatever, and then we can scan the data and then replicate. So this is one way of pulling. But recently, and this approach is might requires a quite high level of entry. But there is another approach which was like developed in collaboration with our end user. Is the approach to use a standard in the delivery of submission packages, which are quite getting into the market. One of the standards are BUG. BUG is a format which allows you to pack all your archival information into a single file and put it into the system. But this file as well might not contain all the data you have, but might contain as well references or links to the files, which has to be downloaded from the internet. And our system is pulling the data, combining everything into one package, validating, and in the end, performing the archivization process. Another approach is a simple fetch file. So you prepare the single text file with URLs to your data, expected sizes, expected checksum code, and our scripts are downloading them. But as you see, these approaches are quite flexible in the description because even though the BUG became some standard, there are several variations of this BUG. How to preserve, how to deliver the metadata altogether, how to connect all these things if there are a lot of data, and there is a lot of variation in practice when we start digging with them. And the same, the fetch file is as well something which is completely unstandardized. It's just the typical way how some of the IT guys or DevOps guys are delivering the rest of the files. And there are other approaches like ls minus alert files, which you can get the data from the internet. There are plenty of variation of that. So to address that, we implemented a new engine, which is called automation engine. Apologize, my mouse is getting crazy today. So automation engine based on Open FaaS and Kubernetes and lightweight FaaS function, stateless functioning services. So you are able to implement your simple a few liners plugin into our system, which does the job for you, which interprets the file, the format you want, and process the information at our end and in the end achieve what we need in this case. It's pooled. Of course, the people start looking at this not only for the pooling data, but as well for the processing data, computing, because it's completely open. So if you get access to the open FaaS, if you have Kubernetes behind the scene, you have a scalable directory processing, which allows you to scalable function processor, which allows you to process anything and any complex system. And I will demonstrate that in a minute. Okay, so typical architecture, what I was saying about that is like we have the deployment, the provider, which has open FaaS, and people can push the data using the REST API S3, or there is an open FaaS which is able to start downloading the data from the internet. Also, in our typical deployment, and this is like as well demo deployment. We are using Elasticsearch or OpenSearch version compatible to index the data which are archived for data discovery, which is important part of the archivization, not only archive, but be able to answer the question, what do you have? Okay, so what is like the new features? And we have like several new features to be able to address and be able to deliver that vision about the long-term preservation. One of the new features is automation engine. The automation engine, this is probably the most complicated feature I want to introduce today, and I will give you a live demo in a matter of a few minutes, just a few concepts before we start. We are introducing a kind of plugin into the system, which we call FaaS Lambda, as a function of the static lambda, which practically is a function usually written in the Bash or in the Python, in any very simple programming languages, incorporated into the simple Docker container. And this function usually needs like the input arguments and produces some simple result. And for instance, the function which is downloading the files as an input argument needs to get a URL from the internet, and as a result, it says, okay, I downloaded and I made the process. Okay, so this is a simplistic word, but in practice, this function as well might deliver exceptions or might deliver logs, so we know what's going on inside of those things. Of course, this function might well have some side effects. So this function not only delivers the data, but as well might register something, calling other REST APIs and doing something in the system. So this function, to do the side effects, sometimes needs to get security context. And this is the most important and most unique solution which we deliver now in our system. So all the functions which we are running are executed in context of the user who is running. So we are passing to the function security context in terms of the macaron tokens, which are very limited to in the capacity, in the functionality, but being able to execute whatever this function might need on behalf of the user. So this security context of the function doesn't allow you to write the script which deletes the user account, but is able to reach certain files or reach certain objects in the system, and being able to save the data in the place where the user who is running the function. And to monitor that kind of things, the functions deliver heartbeats and being able to save some information for further processing by other functions. This seems to be very complicated, this part, but in practice, it's extremely simple. We have like a functions which can be achieve all of those in no less than 50 lines or even less. So this is not very complicated. Of course, it depends on the complexity of the function. Okay, so this is like a single container of our flaggable architecture. So we have lambdas, FaaS lambdas, which are running on a scale on the Kubernetes. So as the user, you always think about execution in one instance, one request, but the scalability, scaling up is done by the queues, Open FaaS, Kubernetes, and even auto-scalers of the infrastructure. So it's possible to deploy that kind of infrastructure in the way that it's automatically scaling up, getting the resources from cloud and scaling down when there is no traffic. This is very important in the archival world, archivization world, because the processing job might be not often, and there is no need to keep the large processing infrastructure just to be for the occasional jobs, acquisition of occasional jobs. So of course, if you have a plugin functions, in practice, single function is not enough to achieve the complex scenarios. And then what we introduce, we introduce the concept of workflows. Workflows where you can connect the functions, the lambda, together into some sort of parallelism way, different parallelism approach. And these functions are run in proper order or proper scalability. Going further, we introduce the last concept, which is like important for the execution of those things, is the stores. So not only we are able to have the results, but able to put the information into the stores in the persistent memory while the execution of the workflow is done, in order to be controlled other functions. So for instance, we have like the function which validates the list of the files and get the list of the files which are passing the validation and matching the valid format, and put this information into the store and into the store, which is a list of files, and this store is the input for the other functions in the next lane. So in that case, we have some sort of cascade of execution of lambdas are producing data for another lambda, and another lambda are producing the data for further lambda. So in the end, we get some nice workflow, which brings easy for us to bring a complex scenarios by using a very simple flag, which is the lambda. Okay. So last but not least, we introduce the thing which gathers all these things together into the inventory anatomy in Onedata. Then you get the workflows and you are able to get the workflow stuff. Okay, this is our theoretical introduction, but now something about the practical math. So for those who never seen Onedata, this is our interface. Hope Ian, can you confirm that you can see my browser now? And okay, thank you much. So now you see my browser, and this is like how Onedata looks like. Usually we are logging using the entry page. This is now a demo platform. Technically, each of you can go there, but we on the production we use EGI data hub.com. So I'm logging now using the EGI credentials, and after a few seconds, I'm back to the system, and I'm logged as a user which came from the EGI data hub, and all my credentials and all my groups are downloaded from the internet, integrated in the system. So these groups might be later used for data access control if needed. But today is not about that part. Today is about the data archiving. In the matter of Onedata, we have like a concept of data space. So you might create several data spaces. I have access to a few of them. And you can, of course, when you create a data space, you might invite people to your data space, which is like the part of our demo. While you are inviting the people, you might give the people some access. So I will, just for this demonstration, I will give you access, all of people in the world, to this demo, to this environment, and you will be able just to view the space and just to read the data. So you are not able to scramble my part. So and then if any one of you will just log into the demo Onedata.org using any credential which is working there, including EGIs, you will be able to see this part. But what is like that part? So what in Onedata, we have like a platform where we can upload the data, manage the files easily, and do that process. It's a different demonstration, not for today. We are focusing only on the long-term optimization. So as I said, we have like several approaches to the data injecting, submission to making. So the most simple approach is like I'm switching to my data. I want to, let's say, move the directory. This is my result of my publication. I would like to preserve it. I would like to get the DOI in the end. I would like to make reachable for a very long time. I will just drag and drop, and I'm uploading this file. This drag and drop uploader is basically uploading data structures, the whole directory, and my simple collection, 273 files. It's green now, so it's there. Of course, it's there, but it's not archived yet. This is just a, let's say, submission information file. It just uploaded the data there using one of the available methods. Another method which is might be interesting to you is like the method of pushing the data using rclone, which is the very popular method in the system world. So to do that, thanks to that, we implemented S3 gateway to Onedata, which allows us to give access then in the protocol using S3. And thanks to that, we are compliant to S3 protocol. Because we are compliant, because we are compliant to S3 protocol, we can use standardized tools for which are working for S3. For instance, rclone. Not switching to the black screen. If you confirm that you can see my black screen now, just for testing, because I'm not moving, talking to the wall. I hope I can. I'm casting my black screen. So in the rclone approach, it's very simple. My task now is to upload tech COVID files into the system using the rclone. And I have like the rclone command, which is basically using a command copy and taking the directory sec covid from here and put the directory into the demo profile, EGI workshop data space, and subdirectory sec copy. And before I go there, what is like you probably won't know what is the demo profile. It's like you can get it like from in the system from config rclone. So this is like the simple access key, secret key, and endpoints where I can just connect the system. And there is a multi-thread streams which are able to we will be working in 10 streams from now. Okay, so I'm rcloning the data. So now I'm just pushing this several hundred of files into the system, and now rclone has pushed all of them, and now rclone is checking if is validating if the checksums are correct. All of that is using S3 protocols. It's not a big collection, but it takes a few seconds to approach that. And what we have now is like we have two collections: the mid-COVID, which are just uploaded by manual upload, pushing the data, and I have a second information package, sec-COVID, which is uploaded by the RED API, but in S3 API, which is like a RED. What is interesting about that part, when you are using S3, we are as well putting the metadata about the checksums. So the S3 protocol is saving the checksum. When you are using the normal traditional graph user interface, you don't have this information. This checksum will be calculated during the process of optimization for further process. So this is like these are the most common examples how people will use our system into the push method. But there is another approach. It's like the pull method. That's why we introduced a very complicated machinery, which is about it's called automation workflows and automation engine, which is available in here. So I can see my two workflows I have. One simple workflow is like the workflow for downloading the file. Is the workflow which processes the fetch file structure. It checks if it is correct, and then it downloads this file using curl method, and then it calculates checksum and validates if the expected checksum is corrected with the thing which we download. So you see, it's a very simple structure, but not very standardized. So people might have a different processing pattern. So that's why we build a complete machinery for automation of all. Okay. So how to approach that, and what are the benefits from that? So I will ingest a simple file. I have like the let's say 100 files fetched. So this is a fetch file which contains the linear URLs of the data. And by the way, I will show you. This is like a very simple file, which is based on the URLs, expected size, and the directory, and where the data should be put. Okay, so as you see, the file is like 500 kilobytes, and I want the pooling method being done by the server. So what we can do now is like run a workflow. This is the download fetch file workflow. And as an input, we get a single file. We could have multiple fetch files here in one batch processing. And as a destination, I need to provide a directory where all the data will be unpacked. So we don't have the directory that yet. So we have like the, let's call it fetch. So now I'm ready. So I'm starting in processing the fetch file to the destination. So I'm running the workflow, and the workflow is slowly starting. The workflow is starting on Kubernetes environment, which is underneath of my platform, and I can see what's going on there in terms of the infrastructure. I'm pulling the you can see what these are the messages from Kubernetes. It's already done. It's killed and terminated because it's finished. So we can monitor the processing. Now we go to the second lane. In the second lane, we are slowly downloading the file. And one remark: our demo infrastructure is on purpose configured to do the single dot processing. So there is no parallelism in this workflow open FaaS processing, in order to slow down the process so I can do the explanation of the demo. So we have like as well the result from the Lambda showing us what's going on, that we are downloading the data from the internet, there is the speed how we are downloading the data, how many files per second are we processing, and all of those practical information, which is delivered to our system through our system. This information is done as a result of the side effect of the Lambdas. Is a very simple way how the Lambda can monitor and report the process. But these information are very important if you are processing a large scale data, because when I'm downloading a terabyte of data, it might take ages to process a single file, and I don't know what's going on inside. So that's why we needed to introduce all these lambdas and all this graphs, all this configuration, the whole lambda lanes and all this configuration is configurable at the workflow level, in that way that you can completely build a different scenario. It's up to you what's going on there. So as you see, the downloading was faster than the checksum processing, and there is a time shift. So there is something is like processing, and now we are processing the data. This system is on purpose extremely slow. Otherwise, this data wouldn't be. It would be very difficult for me to explain what's going on. So now there is a checksum processing going on. It's finished. It's done. And what I see is green, so it means that it downloaded 98 files from the internet. So we can see what's going on. I will go to my files. I will go to my fetch file, and I see there is a directory structure with files and the directory down there with the different files. And there is as well some metadata with the checksum counting as a result of the processing which we compute. So the system automatically as well added the checksum of the data being downloaded from the internet. But how to check if this is 98 files? We introduced a new feature in our system, which is called accounting and capacity management. At every structure, every directory level, now you see the size. and the sizes shows you the statistics about this particular directory and hierarchical subdirectory, and gives you information about the logical file size name, physical size name, and number of files, number of directories. And as you see, 9085 is there. And this is like the time series things, because when we are extending the directories, this capacity is growing. I will do the demo about that later if we have enough time. Okay, so this is like the part of the what we did in this automation process. So if we want to go with the more complex scenario, there is a buggy scenario, but I will start the bucket and I will explain you more about that. So the bucket is like a black box. It's a thing which contains the information about that, contains all the data, and some of the data are part of the bucket, some are the part of the fetch file being inside the bucket. The bucket brings as well all the checksums, all the information of the metadata, custom metadata, which might be part of the collection. And this is like the kind of encapsulated thing what you want to run here. So I will run the workflow again here, but this is not the fetch file, it's a Baggit thing. So I'm using the Baggit uploader workflow, which is more complicated. So it takes the single Baggit file as the input, and then it processes. It expects a similar directory where I will unpack my data. So I'm creating a directory, Baggit 700, and create a directory there, confirm, and run web. As you see, this workflow is way more complicated in practice. It does a lot of things. I will explain you in briefly what's going on. First of all, we are validating if the Baggit file is a valid Baggit by itself, which we are checksumming the Baggit itself. Then we are unpacking the information from the Baggit and unpacking the data being delivered with the Baggit, because Baggit is a hybrid delivery package. You might put the files into the Baggit file and some of the files being downloaded from the internet. So when we unpack the Baggit file, we get the list of the files to be downloaded, and there is like a dozen of files to be downloaded from the internet. And we can see what's going on there. These files there are a few bigger files. As I said, this demo is not very fast. So it's like, so we are downloading it from the internet with the speed, like this open internet file. This is like the typical repository. So you access there in the internet. And as I said, there is no parallelism on purpose. So we are just processing file by file. In normal deployments, we will be processing in parallel number of files that, thanks to the open file scalability. But this is not nothing about our cover. So this is not what we are demonstrating. So we are downloading the file, but coming back to the presentation, I would like to explain you a few words about the Baggit itself. So switching back to the presentation, Baggit itself is a popular file format which is usually delivered as a zip or a tarball or a tag zip. So it contains usually the following structure. It contains the information about the Baggit. It contains the data file. It contains the fetch file, the things which need to be fetched from the internet, as we did before, and some of the manifest for the checksums of all the data which you have there, and metadata itself. So this is like the minimum Baggit size file, but there are more complex. This is like the capping of the fetch from the Baggit. So this is very similar to what I was showing you before. So there are URL sizes, directory, and the checksums are taken from the other file. So this is what we are processing. But in practice, when we were working with the real users, there were like a lot of variation in the way how metadata, custom metadata are provided, how they are generating from the different systems. In practice, the standard is violated in a few ways by the popular tools there. And that's why we decided to be more flexible and deliver a workflow platform instead of just building a single file format processor. If you come back to the processing, as you see here, this file format is almost there, and we are calculating now checksums of these files, and in a minute we will be archiving this file. So if you want to see the chart the file downloaded with some speed, and the download was not very nice. Now we do the checksum processing for different checksum SHA 512, 256, and so on. And we are now starting the process of archivization, because this process is not only the creating the downloading the data, but as well archiving it. What it means to archiving the data, I will explain you in a second. So what we get we get a 700 megabyte of directory being downloaded, scrapped from the internet, validated, and preserved, and get a flag which is called a data set. But how to do that manually? So to achieve the archivization, there is we introduce a few new features into the system. And I will switch to my presentation. And in the presentation, we introduced a few concepts. First of them is like the data set, which is the principal concept in the OAIS. And then we introduce IPs, DIPs, and incremental archives. So in our system, you can define that this part of my system collection is the data set, and my data set might contain the hierarchical of other data sets, and I want to create archivization packages and distribution packages out of them. So how to do that in the system manually? Because when I was uploading the baggage, everything was one step, and I will just show you how to do that in this. What we have is here, we have this fetch file for which you downloaded from the internet in a minute before. So we can just go here and that this is a data. So establish a data set. On top of this directory and subdirectories, you can establish a data set. So when you are establishing the data set, you might protect the data from being altered, but keep the metadata open for changes because you are working on this data set. You want to prepare it for archivization. The point is like you have like a snapshot of your data, but it's not clean yet from the point of the descriptions and metadata. Maybe you want to add something here. So maybe you want to add some demo and metadata level one, whatever it means for you. So the custom metadata, which we are saving here, and this particular file gets extra metadata being protected. Okay, so when we reach the level that everything is clear, we can either block the write protection and wait for validation. So now even the metadata cannot be changed. And even though this directory can't be deleted because all the deletion functions are blocked because it's protected by our system, data write protection. So what I can do is I can create a snapshot of my data. So it's an archive. So what I want to do is like I want to give some description. First archive demo. I want to use a layout packet. I want to include the distribution information package in our system, and everything should be processed. I cannot enable incremental yet because incremental is possible on the data sets which already have some archives. So it's not next step. So I'm creating this, and the system is on building the archive. It's copying, validating all the data of the snapshot and building like a persistent snapshot in the format on the backend storage in that way that you can go directly to the storage. Even when data is not existed there anymore, you have access to your storage and you will be able to read properly this data. You can browse, of course, this how it looks like. As we asked for the bucket, so the archival package is in the bucket format, which you already know. So the data is there in the form of the bucket. There is all this metadata there. The manifest are generated metadata JSON with all the metadata which we give to the system, and all the information are generated. And we have like a distribution information package, which is like in the human readable form, which is like there for using exactly like human readable form. But this is done in the way that it's not taking any capacity because we are using a thing which is called a hard linking, a virtual hard linking in our system. So the AI is consistent. AI is a full package. It's like you can easily read it, but deep is like the references some of the parts of the system to avoid duplication of data if the deep is identical. But there are different strategies how the deep are created. So I have a first snapshot of my data and what I can do with that. Usually I want to share it to the internet. So I want to publish it. I want to get the DOI of this archive. So I create a share. I create a public share. And what I can do is like now I can make it and publish as open data. So I'm publishing using the field handle. I'm processing. I'm providing some doubling for metadata, which is automatically filled up by the basic things. I provide a description like the markdown description. Uh, and I have a marked like README in the GitHub. And when I'm ready, I'm just processing the data and publishing it as an open data. And I got it, open data, handle to my archive. This is like the persistent version of my data. And when I open this link is a part of the citation. The system delivers me a view of this data repository with the file, with being able to read and access properly. So this is like the full flow of the very simple scenario, which we did manually. And in the same way, what I did manually, I created a data set, I created an archive, I did a few steps manually. The Debuggy did it itself. I get a data set and I get an archive. And this archive is there, is preserved, validated with the proper settings. So as you see, this automation brings a lot of flexibility. And the process, what we did with this is like our custom decision, how we build the workflow itself. So that's the first glance of the system. Of course, we deliver as well the data discovery part, which is like we did another webinar on that in EGI, how we do the data discovery part. It's done by the discovery features and things which is called harvesters. I will not deep dive today as we did at the previous webinar, but I will just click a few links, and then you can have like a harvester, which is indexing the data and brings the data discovery interface, which I can do very quickly, but without the workshop. Now we are start indexing the data and I'm indexing the data and the data spaces. Sorry, no. It's already filled up with the data. You can see the index is now already 100% full, gathered from all the providers, and the data discovery is there. And we can start discovering the data by the properties or by any keywords inside of the data, which we just create. So that's basically the full flow of this bucket sort and archivization, how it works. So I guess we have like coming back to the slides, I will just to summarize what we do. So we deliver data sets, we do the AIs, deeps, incremental archives. Well, I didn't show the incremental archive. So one more thing. So let's say this test file is not all what I wanted to have. This is like my archive, but I want to alter that part. So what I need to do is to, first of all, to remove the write protection from this, because I cannot alter it, as it was blocked for the previous snapshot thing, but it's not needed that anymore because snapshot is already there. So we can reopen the data collection. And now I can, let's say, grab a few files and drop a few files there at the end. So because I forgot all those cells. So what I can do is I can go back to this data set and I can create another archive. So let's create an archive. And this time it's gonna be incremental and as well using deep, as well using Baggage, like a second. So I create another version. The whole thing is building, but it's building in that way that it's building a cascade of the archives, and the cascade of these archives are depending to each other. So bringing the whole thing and using only the space which is needed for the change of the file, everything else is logical reference inside of our system. But how you want to extract this data from the system? What is the access point? Of course, there is a way you can get it by using Tarball. We are having a feature for Tarball generation on the fly. We can deliver you a huge Tarballs from the system, terabytes, petabyte Tarball files, which is ridiculous, of course, but it's like generated on the fly by our system. And you can even stop, you can even break the downloading and recover the download from the broken part. So I can download this part, and even though it's like I just have in my bucket new files there, everything else is you see this is a new file there, everything else is the reference, logical reference. So no matter of that, if I no matter of that, no matter of that, if I click here, I'm getting the full collection, full archive in the form of a tarball, which is extractable, and basically it's what we need. This is needed for exit strategy from the system, being a part of the essence part of the system, keeping the long-term data preservation. Okay, so coming back to my presentation where we do the summary, and we have a few minutes for the questions. This slide that we introduce this all the hierarchy of embedded archives as well as more complex scenarios, and we introduce the hard links, symbol links, just to achieve this page optimization features, so you avoid the data being duplicated multiple times in the places which you don't need. Because if you do the long-term archive, usually you want to archive the full file. It's not about scrambling the changes blocks. It's about downloading the whole files, but you need to have a strategy how to download everything. So, and there are the performance improvements. This is like a graph about the push ingestion. We are by the single server, it's like about 1.5 gigabytes per second, more than 10 gigabits per second interface. It was running on 20 gig servers. So all of the things are there, and we are delivering a uniform environment which delivers your data management, data discovery, which allows you to push data. Then later you can do the data processing using our methods for virtual file system access, which was not a part of the presentation today, of course. And last but not least, everything is licensed by Open Source and MIT. So last thing is like the hierarchical capacity. We introduced this part, so you have the full information on every single level, how much space and where is this particular directory taken, so you can easily manage the archives later. Okay, so that's it. If you have any questions, please write it down, the question and answer. I will be more than happy to answer it. So please.